Do you remember the concept of the independent current source introduced in Lecture 7? We asked the question of how to get an independent current source. We will offer the answer in this lecture. Before answering the question, we need to discuss about the serial parallel connection of the independent sources. Let's begin by looking at the serial connection of the ideal independent sources. For a subcircuit with n ideal voltage sources connected in series, if we marked its port voltage and current reference directions as non-associated reference directions or active sign convention, what kind of the expression for U and I can we write? For all the voltage sources, their currents are the same, but the current is determined by the external circuit. We can only write a KVL equation in this circuit, that is, the voltage drop from here to here is equal to the voltage drop from here to here. That is U equals US1 plus USN. This is all UI features for the circuit. It can be written as U equals US1 plus USN plus equals USEQ. That is to say, it is equivalent to an independent voltage source. The second is the serial connection of an independent voltage source and an independent current source. We adopt similar approach by setting the reference directions of the port voltage and current designated as non-associated. For the voltage source, its current is determined by the external circuit, but the external circuit contains IS. Because they are in series, the current of the voltage source must be IS. For the port, we know I equals IS according to KCL. Of course, the voltage is determined by the external circuit. If we know the voltage from the external circuit, in this subcircuit, we can calculate the voltage across the current source by KVL. So for this subcircuit, I equals IS is the only equation we can write out. That is to say, the subcircuit can be equivalent to this. Next, we discuss the parallel connection of the ideal independent sources. The first is the parallel connection of the n independent current sources. For the non-associated reference directions on the port, we can write KCL equation on this node, that is, I equals IS1 plus ISN equals ISEQ. That is to say, it can be equivalent to an ideal independent current source. For the case of ideal independent voltage source connects with the ideal current source in parallel, what can we get under the condition of the non-associated reference directions? It is clear that U equals US. Of course, I is determined by the external current. Once we determine the current I, we can get the current IS by using KCL on this node. The analysis of the circuit is completed. For such a port constraints, this circuit is equivalent to the circuit. A further discussion is necessary here. Look, an independent current source connects with the independent voltage source in parallel is equivalent to the voltage source only. I have a question here. What is the role of the independent current source? Maybe you are right. As we've just discussed, the port current can be get from the external current. Combined with the value of the independent current source, we can get the current flowing through the independent voltage source. Then we can work out the power of the independent voltage source. In other words, the current source connects with the independent voltage source in parallel determines the current flowing through the voltage source and the power of the voltage source. Similarly, if an independent voltage source and a resistor are connected in parallel, it is equivalent to this certainty. Because the current flowing through the resistor or its voltage can only affect the current of the voltage source. We reach the conclusion based on the parallel connection of the voltage source and the current sources. I suggest that you expand this conclusion to the serial connection of the voltage source and the current source. You will find the similar ideas.